Hey guys, welcome to the channel. This is the platform engineer. In today's video, we are going to explore how or what exactly layer 1 is in the network's OSI model. And this is going to be the first video of the series. I'm going to be covering all the way up to layer 7. And the purpose of each of these videos is to demonstrate what's the purpose behind each of these layers and how do they help from a network point of view, and then what's the limitation of each of this layer, which would then help us understand why the other layers are necessary. Now, without any further delay, let's go ahead and get started. So what is layer 1? So in layer 1, we are talking pretty much just a physical transfer of the data, right? Now, this physical method to transfer the data from between different devices, there really can be just three mediums or three methods. The first one is the most common, which is some sort of way to transfer electrical signals through copper wire. And then another one's quite famous as well, which is, I'm sure everybody's heard about it. It's fiber optics, which is basically using light as the physical method to transfer data from one device to another. And then obviously we have Wi-Fi. Wi-Fi is basically using antennas, different frequency ranges to actually transfer the data. But these are the most three common methods to transfer data from between devices. Now, one thing to keep in mind is that it's quite important that the devices that are connected or that want to transfer data between each other are connected through the same shared medium, right? If you've got one device connected to another device with copper wires, then you can't be adding another third device to that using Wi-Fi and expect them to be able to transfer the data that they all understand, right? In order for all the three devices to be communicating each other and understanding each other correctly, they all must be using the same shared physical method to transfer the data, whether that's a copper wire or a fiber optic or Wi-Fi, but that method has got to be shared, right? And the reason is because there are different standards defined for each of them that dictates or that helps the device that's transmitting the data to it's basically a specification that helps the device that's transferring the data to transfer the data into the medium in a way that the receiving device can actually understand it, because it's got the receiving standard for that particular medium too. And this specification really just entails the transfers of binary data, right? So just raw bit streams. We're talking zeros and ones. That's all you're transferring. But the specification is set out in such a way that depending on how these zeros and ones are being transferred, the devices this can then be interpreted to understand voltage, for example, or the distance the data is traveling across, the modulus of the data, and a few other physical factors. And that's all being encoded in binary between zeros and ones when transferring between the different devices. And it is really important that this encoding of the raw bit streams are actually done correctly. So if you're using a different shared medium for another device, then you're not really going to be using the same specification as the other devices. And now this method the problem with this method is that it's kind of dumb, right? If you look at it, this example, right, laptop 1 goes in, sends some data to laptop 2 over let's say this example, this is a copper wire that's transferring electrical signals between them two. Now, it may look like it's exactly fine and there's no problem with it. You're just transferring data from laptop 1 to laptop 2. However, let's go into this scenario. Now we've got a hub in between, and we've got 4 different devices that are transferring data into this hub. Now, if laptop 1's transferring the data and this data is intended only for laptop 3, what do you think happens in here, right? All the 4 devices are connected to the hub. So laptop 1 first sends the data to the hub, and hub is a layer 1 device. What it does is it transfers the data to all the remaining 3 devices. So laptop 4, laptop 2, and laptop 3. So not just laptop 3, even though you just wanted to send data from laptop 1 to laptop 3. And you want to be able to do that in a network where all 4 are connected through the same shared physical method, right? In this example, a copper wire. Now, this is a limitation of layer 1, which is why it's a bit dumb, because you can't really specify just by using layer 1 a specific device address. You can't do that. And now, on top of that, you also can't control in layer 1 when is which device allowed to transfer data, right? So laptop 1, laptop 2, and laptop 3, as well as laptop 4, they all could be transferring data at the same time. And when you think all the data is coming to this hub, which is a layer 1 device, so it basically just takes the data and sends it across to everything that's connected to it, right? It doesn't do any sort of device lookup or address, as I mentioned earlier. So everybody's transferring information and everybody's also getting it, but this information is not in any order. You got to remember, it's just raw bit streams with just containing zeros and ones. So what this means is that this is basically, there's going to be a collision. What collision means is that if multiple devices are transferring data at the same time, and the data gets corrupted, because there is no control over who is transferring when and which device is the data addressed to, and there is a massive overlap of the data, interference of the data, so the data is corrupted. This is known as collision. So layer 1 by default doesn't come with any collision detection mechanism, right? And this is bad, because if you think about it, if you're connected, if you've got a local network setup and you've got 4 laptops connected and you want to send data between these 4 devices, you want to make sure that the data that's being sent is not corrupted, right? Whether you're using it, for example, for playing a game, or you're just transferring some important data between your local network, you want to make sure that the data does not get corrupted. So that's kind of a limitation of layer 1. Just to recap, the purpose of layer 1 is to basically just provide a shared physical method to transfer the data, and also specify the standards for transmitting data into the shared physical method, as well as specify the standard for also receiving how the data is going to be received from the physical method. And data here again is just raw bit streams, zeros and ones, but because of the specification, these zeros and ones can be translated to different physical factors like voltage, modulus, distance, and etc. Now, just to reiterate, the limitations of layer 1: no device addressing, and multiple devices can transmit data at the same time, causing a collision. And this is why layer 2 comes in. We'll go into layer 2 more in detail in the next video, but essentially, just to give some overview of layer 2, is that it comes with a mechanism called media access control. If you must have heard about MAC address, which is basically what enables specific device addressing. So that would then enable laptop 1 to actually transfer data to whichever laptop it wanted to, specifically just for that laptop. And it will also ensure that there is some sort of access control on who can transfer data when, right? In this particular example, this is just like somebody coming in the room and shouting. That's what layer 1 does, basically. It's kind of dumb. It doesn't actually transfer the message to someone specifically. It just sends the message to everybody. But yeah, we'll go into more detail for layer 2 in the next video. But if you have any other questions or feedback for this layer 1 video, feel free to leave them in the comment. And yeah, I shall see you in the next video. Thank you. Bye.